Show that root 5 is an irrational number. Show that root 5 is an irrational number. Okay, I am going to prove it as an irrational number by using contradictory method. So, in that method, firstly I am supposing that root 5 as a rational number. If it is a rational number, from the definition of rational number, root 5 can be written in the form of p by q, where p and q are integers and p and q are co-primes. Here, co-primes is an important word. Okay, on based on this we are going to prove this. Okay, firstly, you should know about the co-primes. Co-primes is what? Two numbers are said to be as a co-prime if there is no common factors other than 1. Let me take an example. Okay, 24 and if you take another number as a 25. Let me take, okay, 24, 25. And if you observe these two numbers are not having any other common factors other than 1. So these two numbers are said with what? Co-primes. In the same manner, 24 and 27. If you take 8 3 the 24, 8 9 the 27. So these two numbers are having a common factors 3 other than 1. So these are not a co-primes. Okay. So here I am supposing that p and q are co-primes. Co-primes means what? There is no common factor other than 1. So in this case, and what I am doing here, I am going to apply squaring on the both sides for this above equation, so that this can be written as root 5 the whole square is equal to p by q the whole square. So square and square root both will get cancelled. This can be written as phi is equal to q square by p square by q square. I am transporting this q square to other hand of the equation. I can write it as a phi q square is equal to p square, and this is the only I wrote it as a p square is equal to 5q square, and I am supposing it as a first equation. And if you observe this equation, in this equation I wrote p square as a 5 into something. I wrote p square as a 5 into something. That means 5 p square is a multiple of 5. That means 5 divides a q square. 5 divides a p square. Here, as 5 divides a p square, then 5 also divides a p. 5 also divides p. That means if 5 divides a p, 5 is a factor of p, and p is a multiple of p. So p is a multiple of 5. If 5 divides a p, 5 is a factor of p. 5 is a factor of p, and p is a multiple of 5. Okay? If p is a multiple of 5, and we know that the common general form of the multiple of 5 is 5m, so I am supposing that p as a 5m. Okay, I am supposing that p is a 5m, and here we need to understand that 5 is a factor of p, and p is a multiple of 5. So that's why I wrote it as p is equal to 5m, and this value I am going to substitute p is equal to 5m in the equation 1, and we know that equation 1 is p square is equal to 5q square. In this I am substituting that p is equal to 5m. That means p square instance 5m the whole square is equal to 5q square. This I can write it as 25m square is equal to 5q square, and transporting this 5 to other hand, it becomes a divisor. So this I can write it as 25m square by 5 is equal to q square. 5 on the 5 the. So this I can write as 5m square is equal to q square. From this I wrote it as q square. Q square is equal to 5m square. And here you need to understand that q square I wrote it as q square I wrote it as 5 into something. That means q square is a multiple of 5. That means 5 divides q square. 5 divides q square. That means as 5 divides q square, then 5 divides q also. If 5 divides q, then 5 is the factor of q. 5 is the factor of q. And here you need to understand that 5 is the factor of q. And in the above observations, we got that 5 is a factor of p. But what we suppose that p and q are co-primes. But we got one of the factor phi as a one of the factor of p and q. That means this contradicts the fact that p and q are co-primes. Okay, from above observation we can say that phi is a common factor of p and q. Phi is a common factor of p and q. So if phi is a common factor of p and q, this contradicts the fact that p and q are co-primes. P and q are co-primes. So why this contradiction arises? Means this contradiction arises as our assumption is wrong. What is our assumption? We assume that root 5 is a rational number. If that is wrong, then what is correct? Root 5 is an irrational number. Therefore, by this we can say that root 5 is an irrational number.